most important areas, and efficient handling of waste is an important factor in the development progress of any nation, and therefore effective management of waste is a national priority. So I'm sure Dr. Ashokan Papu and his team and the speakers who are there for today's deliberations, they will definitely show us some path towards solving the problems, and also giving some solutions, and the technologies which are being shared by our colleagues, they will also be beneficial to the industry personnel. With these small note, I would now hand over the proceedings to Dr. Ashokan Papu.
Thank you, Dr. Ashok Kumar. Honorable Chief Guest of the today event and the plenary speaker, Dr. Mohan Raghunathan, the President, Construction Technology Solution Chennai, our esteemed guest and the keynote speaker, Dr. Deepak Bansal, the Joint General Manager of HUDCO from the project side, Ministry of Housing and Urban Affairs. Esteemed our special invitee and special guest, Dr. Anjan Rai, the Director, Central Building Research Institute, as well as the Director of IIP Dehradun, and who is the Senior Most Director of the CSIR system. And esteemed Dr. Anandavalli, the Director, Structural Engineering Research Center, Chennai, and the Team Director of Civil Engineering Infrastructure. And esteemed my Director, Dr. Avanish Kumar Srivastava, our technology presenters, Dr. Sinha, Dr. Prabhagar, Dr. Kirti, Dr. Sandakumar, and Dr. Manoj Gupta. And we have many participants today. They are from industries, from MSME, from Haryana, Delhi, and Madhya Pradesh. And the senior officials from the government, private, and public sectors, they are with us. And many professionals from builders, construction agencies, designers, and architects, they are with us today and watching us from different part of the country. And the director of MSME cluster, Yamuna Nagar, Mr. VP Singh, is there with us. And in addition to that, many professionals, academicians, students from the school, college, and university are there. Aap sabko namaskar. I am Dr. Ashokan Bapu, Chief Scientist and the coordinator of this event on behalf of the director and the Institute, Advanced Material and Process Research Institute, Bhopal. Very warmly welcome you all for this very important event. And this Icen 44 today on the theme, high volume use of industrial inorganic waste for civil infrastructure engineering is one of the major area what we are going to discuss and deliberate on this today event. And I am sure all the participants are there. We have the keynote speech and plenary speakers and special guest invitees, and your all participation and your guidance and your intervention in transforming the technology already developed by CSIR Institute in the area of waste wealth in civil infrastructure engineering is certainly going to make a change and contribute to achieve in creating employment, creating income, and enhancing the income of the rural and urban masses, thus contributing to the industry, society, and the environment. And with this, I once again very warmly welcome you all, and I am sure and you will enjoy this event, and your involvement, your learning, your participation and sharing will going to make a significant importance in the context of Atmanirbhar Bharat, and where the 75 years of independence we are going to reach out, and for which we are going to celebrate the Atmanirbhar Bharat and Azadi Ki Amrit Mahotsav. I believe this day is going to create some valuable outcome, which is going to have a reality in transforming the lab scale research into application oriented, industry oriented programs to create entrepreneurship and facilitate startup and entrepreneurs. So with this, once again, I welcome you all, sir, and thank you very much. Namaskar.
Thank you, Dr. Ashokan Papu, for highlighting the importance of the theme and the session. And now moving forward, Now I would request Dr. N. Anandavali, who is the Director, CSIR, SERC Chennai, and also the Theme Director of CIE, Civil Infrastructure and Engineering, to give her opening remarks, please.
Thank you, Dr. Ashok Kumar. Sri Mohan Ramanathan, Managing Director, Advanced Construction Technologies, Sri Deepak Bansal, Joint General Manager, HUDCO, Dr. Anjan Ray, Director, CSIR Indian Institute of Petroleum and Director, CSIR Central Building Research Institute, Dr. Avinash Srivastava, Director, CSIR Advanced Materials and Process Research Institute, Dr. Ashokan Pappu, Chief Scientist, CSIR AMPRI and Nodal Scientist, CSIR Subteam on Waste to Wealth, Dr. Ashok Kumar, Outstanding Scientist, CBRA, and Nodal Scientist for Building Physics and Material Subteam of CIE team, scientists from Technology Management Directorate, CSIR, speakers, scientists, academicians, researchers, invitees, industry partners, ladies and gentlemen. A good morning to you all. I'm happy and glad to be present in this technical session on high volume use of industrial inorganic wastes for civil infrastructural engineering of the iConnect event on waste to wealth under the civil infrastructure and engineering team. On behalf of the CIE team, I welcome you all to this event. Waste is a natural byproduct of any phenomena, be it natural as well as man-made activities, including agricultural and industry. Waste is seen as unwanted or unusable material after its design use. Industrialization, which is inevitable for development, also generates various forms of waste which may lead to serious environmental degradation. Efficient waste management is required to overcome this issue and march towards a sustainable future. Recycling and utilization of waste is a significant step towards the protection of the environment and sustainable development. Effective management of waste is now a national priority as seen through the Swachh Bharat mission. Concrete, as we all know, is the second most widely used substance after water around the globe. As we know that concrete is a composite material consisting of binding materials such as cement, lime mixed with aggregate sand and gravel, and also chemicals such as mineral admixtures. So, in with water in specific proportions. Due to its utilization in large volumes, it leads to about 5% of the global CO2 production. The concrete industry is a huge industry that is growing at a faster rate and that leads to the consumption of plenty of natural resources, which puts the non-renewable natural resources in danger of extinction, and the natural resources are remarkably warning day by day. On the other hand, millions of tons of construction and demolition waste residues are also generated. Therefore, the use of recycled concrete aggregate obtained from the construction and demolition waste in new concrete is a solution for effective waste utilization. Aggregates from construction and demolition waste or precast concrete residue seems to be a promising contribution towards sustainability of the construction industry. However, low volume of the recycled aggregates is utilized as partial replacement because while the major part of the waste concrete is still disposed in the landfills. So there is a need to use large volume of these. We have to bring out technologies where we can use the large volume of the waste in creation of new concrete. A recent article also highlights the use of red mud as partial replacement to cement. Indian aluminium industry generates a significant amount of solid waste such as red mud. Red mud is produced during the refining of alumina by Bayes process. It is estimated that for one production of 1 ton of alumina, about 1.2 to 2.5 tons of red mud is generated. So annually we are having around 4 million tons of red mud. So also this red mud contains some toxic elements. So dumping of this may contaminate the soil as well as the water, and also it covers the valuable land. So by considering the cementitious behavior of the red mud into account, we can be used in mortar and concrete technology for construction practices by partially replacing the cement. Again, we need a detailed R&D before we can use this, and also the use of this with the partial replacement seems to be a economical solution, and also it is available free of cost due to the as a byproduct of the alumina industry. Finding innovative solutions for effective management of waste by overcoming the challenges of each form of waste requires special processes the need of the above. Approach of viewing waste as the resource to convert them into value-added products is age-old practice, as it is practiced in this country, but it was not in a formalized manner. And also byproduct waste is waste produced by the industry, so which is any material that is rendered useless during a manufacturing process. Usually they are stored as landfills, as we all know. So either around big cities or around the agricultural fields. Some of them are silica fumes, slag, sludge, fly ash, sandpaper, metals, glass, etc. This some of them can be used in construction, and say for example sludge from steel industry contains considerable amount of valuable metals which can be recovered, and sludge from paper industry also contains high content of calcium carbonate, organic materials and other minerals. So development of building materials must be sustainable, and in the same time they ensure a cost energy that satisfy the modern requirement. The addition of waste to concrete can improve or diminish some properties. So a combination of the waste is also used often, and to compensate these disadvantages. And a detailed R&D is required before putting them into practice. Concrete composite materials are developing on the base of new researches in the recycling domain as innovative option with the environmental, economic, and performance benefits. So I would like to conclude with a Tirukural, which goes, அருமை உடைத்தென்ற அசவாமை வேண்டும் பெருமை முயற்சி தரும், which means do not listen to the feeble mind that says the task is difficult to do, but listen to the mind which says what accomplishment you will achieve by completing the tasks. This accomplishment itself will give all the energy to complete the task. Thank you all.
Yeah, thank you, madam. Thank you for your excellent opening remarks. And as you highlighted the importance of waste to wealth, and CSIR is already having a compendium of technologies 2021, and I see there are 95 technologies that have been listed in 2021, and there are many more to come in the year 2022. And Ashokan is already there for 16 or 17 such technologies which are being discussed today. Moving forward with the program, and now the next item is plenary talk and keynote address. Now I would like to invite Shri Mohan Ramanathan, Managing Director, Advanced Construction Technologies, who is going to give a plenary talk on construction and demolition waste as a replacement of natural aggregate. Here I would like to mention that we at CBRI have also taken up such initiative, and we have used in one of our buildings C&D waste blocks in one or two walls to see the structural and thermal performance of these walls made up of C&D waste. So Shri Mohan Ramanathan is very well known to us, needs no introduction. Straight away, I would request him to give his plenary talk. Over to you, sir. Sir, you are muted. Dr. Ashokan, can you help?
Yeah, I am coming.
Or maybe the host, Palk Dikshit, or whosoever is there, please help.
Yeah, I am calling right away, sir.
Yeah, I've unmuted. Can you hear?
Yes, sir. Yes, sir. Very much.
Sorry about that. So just confirm you can see my screen fully.
Sir, your voice is very
yes,
slow.
yes, very much, sir. Please go ahead, sir.
Okay. So good morning to you all. Dr. Papu, you can't hear me, you said?
No, we can hear you, sir.
Okay, let's go ahead. So good morning to you all again, and good morning to all the directors of the CSAR labs. It's an honor to be here to share my experience and thoughts and ideas for going forward in this topic. This topic is close to my heart since I brought all the demolition technologies into the country over the last 30 years. The next was how to deal with the demolition waste. So the time allotted is very short, so I wish to greet everyone here, including the organizers, the dignitaries, the other speakers, students, and people from the industry. So C&D demolition waste, I'm sorry, I think the screen was wrong, the wrong slide has come in. Okay, let's go into this. What is C&D? What is C&D waste? This is my outline of my talk. Indian scenario, codal provisions, technology and equipment, process flow, little bit about costs, and the waste rules. The Government of India rules are a great important. Sustainability, what products we can get off from this. Just give me a minute. I think I've got the wrong presentation.
Sir, your voice is not coming, sir.
My voice is not coming at all?
Oh, it's coming to us. Deepak, it's coming to you? Deepak ji?
Yes, yes, quite audible. Yeah.
Yes, yes.
Your
We are
slide
able
is
to-
not visible now.
Thank you, sir.
Okay, thank you.
So I got the right presentation.
Yeah, now it's visible. Your
Yes.
slide is visible.
You can put in a full screen mode, sir.
Yeah, I'm doing that.
Your voice is not coming. There is a
I think
possibly
few of you are hearing, few of
mic
you are
is
not
mute.
hearing. But let's go ahead. The slides speak for themselves.
Yes,
So
sir.
waste to wealth, it's a nice topic, and it definitely it is wealth. In fact, the terminology C&D waste must be removed. The waste word must be removed. It must be called C&D resource. That is my opinion. And we got through this slide. And what is C&D waste? Is even the large excavated material is considered as C&D waste. Broken tiles, bricks, metals, wood, stone, plastics. And the most important thing that we are considered in recycling is the concrete. And this concrete can come in any form, as you can see. And the industry throws away the concrete, assuming that there is no technology to reuse. So this is what we are going to talk about. Entrepreneurs here or youngsters can think hard about it and see that whether they can give a future for this. And in India, Indian waste is very different from other country waste. In India, we have a lot of bricks and masonry and the soil. With all the metro projects going on in the country, a lot of soil is being excavated. Even that is considered, should be considered as a C&D waste. So in the word C&D is, as you all know, construction and demolition, but construction waste is really small. Less than 5 to 10% is what is really generated as a construction related waste. Demolition waste constitute the next. So in our country, the brick and masonry and the soil constitute the major portion of the waste. Concrete that we all talk about and a lot of research going on in concrete is only less than 25%. So we must get our attention into the larger waste that we generate in our demolitions, which is it's not always that we demolish large concrete buildings. Many times we demolish small buildings, and this is a real problem because we have to develop this technology of handling the waste, which consists of earth and brick and mortar and masonry. So those of you who may not know, there are almost 20 plants. There are working plants in India. C&D plant locations as of last year, I have listed the plants here. You can see, and many more are on the way. So some of them are maybe, these are known established plants which are published. There may be some smaller mobile plants which I may not know, but this is growing by the day. Swachh Bharat also has helped, and smart cities have helped. Smart city program also entails that a C&D plan must be established. So you can see a lot more plans coming up all over the country, and they need technology. They start with some technology, but they need technology from laboratories like CSIR to make them profitable. So this is not a great, I would say, business venture. Unless the government pitches in for certain things, it may not be viable for the market value of this products. So the C&D waste is the C&D waste consists. It can be in different forms, as you can see. The right bottom is the one with the bricks and broken bricks, which is and a normal recycling yard. I'm going fast because we are short of time. I'll explain these points. So I'm promoting the use of small recycling plants in India. We don't need very large investments. Our volumes are low. So you need a set of equipment which is listed here. I'm not explaining them. They are small capacity. So the item number 4 is the key machine, which is 50 to 100 tons per hour with a magnetic separator. This is what we will need in small plants. 50 to 100. The first plant in India, in Noida, not in Noida, in Delhi, which was set up for the Asian Games, was a 50 tons per hour plant. It is still working in Burari. So my suggestion is we should go for a small plant which can be doubled with really the market picks up. And the conveyor, I will show you a video of this, and a 4-part conveyor where 4 products can be brought out. And a really good plant should have a washing machine, which will wash the aggregates. Unwashed aggregates are not will not produce good concrete. So we must go for a basic washing. This is, and some of you may ask how much it will cost. This whole set of equipment, if somebody wants to set up, if any entrepreneurs are here, it may cost around 4.5 to 5 crores to set up. And of course, we need a small concrete laboratory for material characterization. And that's when this plant can be ready and close to the source is better. A good example is Delhi NCR, where 4 plants are working and they're working full capacity, but still they are not breaking even today. So the process flow for this is for a plant like this. I'm explaining through a flow chart, which is quite clear. And so the C&D waste is received into the recycling yard, stockpiled, and then you get mixed debris. In India, we will always get mixed debris because source segregation is not practiced. It is not practiced by the demolition contractors also. And of course, small demolition contractors do not even know what is selective or source segregation. So we have to go for a secondary breaking in the plant using breakers and pulverizers. And the mixed debris has to be processed through the mobile crusher. The mobile crusher, I will show the video, takes in as a raw material about 300 to 500 mm lumps of concrete. Then the concrete is processed through the mobile crusher, and it is segregated to, depending on what sizes we'll sell. We can have coarse and fine. In South India, river sand cannot be mined, and river sand is scarce. So most of the people would like to go for a manufactured sand. Straight away from the coarse aggregate, from the lumps, it is converted into fine aggregate. Thereby, we do not have to tackle the problem of adhered cement mortar on the aggregates. Otherwise, that is a big issue because it will increase the concrete demand. So after sieving the aggregates through the mobile sieves, it is washed through a simple washing plant, and then we have recycled concrete aggregate and recycled aggregate, RCA and RA as they're called. And sand and silt, in our plants we'll get a lot of sand and silt, and the silt in the form of clay can be sold to the brick industry. or the ceramic industry. So this is what is happening. And here you see there are many plants, many brands of mobile crushers that I talked about available in India, and there are specific advantages in the. Can somebody mute? So mobile crushers are very effective, and these mobile crushers are mounted on excavators, and they can do small amount of. Can you all hear me? Just get a confirmation.
Yes, sir.
Okay.
Yeah.
So these mobile crushers are mounted on an excavator, and these are simple equipment, inexpensive, and you can start with this type of equipment. This is a hydraulic mobile crusher. So these crushing buckets, as they're called, can vary from various sizes of volumes, of capacity, and the intake size. So this is the jaws can be adjusted from to produce what the customer needs, the end product. And then we have the mobile from the bucket crushers. We move on to the mobile crusher brands that are available in India. Mind you, they're all servicing the granite industry, the aggregate industry. They have to change the models a little bit, modify the machines, and they can handle C&D waste. So these simple machines are already available in India in the quarries. We have to, they may not have magnetic separators for steel. They may not have products that we want. So, but these are the common and most famous brands available and serviced and sold in India. So there is no dearth of machinery. Of course, a few of the issues like the dust production are being arrested by dust suppression systems built into these machines. So today we have three types of crushers depending on the end product. So it is the jaw, cone, and VSI. I'll not go into that, but if you're going for a manufactured sander from your C&D waste, you should go for a VSI system. That is VSI's vertical shaft impactor. So the extracting the aggregates, I'm short of time already. I just want to show you one video, and what you see on the left is the raw material, and what you see on the right is the processed and washed material. And this is the aerial view of a mobile recycling plant with a washing system. So you can have 3 products of aggregates, of coarse aggregate, and 2 products of fine aggregates, all coming from the plant. It starts with the loading the crusher here, loading the mobile crusher, and then washing it here. So these plants are all, I told you there are more than 20 plants working in India. It's not new. We also can have a simple type of a simpler one of a washing system. So I just have a short video which I want to show you, which will explain what the demo we have given for Chennai Metro Rail, where about 30,000 piles are going to be installed, and we wanted to educate them that pile heads can be recycled because it's pure concrete and it's quite simple. Here you will see a mobile crusher with the separator system. I'll not run the whole video for want of time. This is the mobile crusher. This is a 3-part screen, and this is the after. You can see it yourself. This was a demo in Chennai for the Chennai Metro Rail. This is a drone video, and the target was to ask them to give the pile heads, about 30,000 pile heads for recycling. This has to come in the specifications of the tender. And I'm also talking to Engineers India for a very large refinery in Rajasthan, where about 50,000 pile heads are available for recycling, and they are very keen to introduce such measures. So this is a simple mobile recycling plant, 70 tons per hour. It's fed by an excavator, and then the products are separated by screens, 3-part screens. So So this is the three-part screen where three products come in. And stop here for want of time. We'll move to the next slide. Now a little bit about the modifications to IS-383. IS-383 for aggregates have been modified to adapt the C&D waste material. The two terminologies RCA, which is recycled concrete aggregate, which come from concrete, or recycled aggregate, which is mixed with brickwork and blockwork and all that. The code is very clear about it, and the code is now enabling contractors and consultants to use it. In India, there is a lot of hesitation to use this kind of material along with mixed with virgin concrete, but it's possible. A large amount of demolitions are happening across India, and wherever I am involved in large projects, I'm trying to promote, first convince the owner and then the RMC plant to use this as per the IS code. This is a large demolition done in Cochin, Maradu, where we have recycled almost all the materials into some products. Maybe they are blocks or washed aggregates. So there are many uses for this, and it's all in the literature. But in India, we are already, CRRA is using it as sub-base. The plants in Delhi are using them for many non-structural products. But I'm yet to see structural products coming out, which as per IS 383, which allows them, or as per the Government of India rules, which are very clear. So we can use it as a road sub-base very safely. We can use it for low strength concrete. These are the things allowed and we can use it as sub-base for the sports facilities. And we have enough guidelines. There are guidelines and books published by many organizations. Indian Concrete Institute has its guidelines. Building Material Technology, BMTPC, has their guidelines. Pollution control boards have got their guide, all to addressing the C&D waste scenario. So it's only question of the consultants and owners accepting it. This is the extract from the code, which says recycled concrete aggregates can be used in reinforced concrete up to M25 grade only. I understand this is being enhanced. That 20% is going to be increased to 40% in the next code. This is what I heard. But only with practice we can change this. And if it's a non-structural concrete less than M15, we can use 100%. So you can go through the code yourself. So the code has enabled this very clearly. So we must take advantage of this and go forward. And some of the applications we can use the recycled RCA or RA aggregates. There are plenty of them. I'm already exceeded 5 minutes of my time, but it's impossible to cover this subject in 15 minutes because this is only a plenary talk. I think I will see if I need any other important slides. Yes, in India, I have seen a lot of landfills being good fertile lands being covered with this. So we should stop this. We should use this material back into our system. And our rivers are getting choked. We are learning this. So the careless use and the careless use of this material by public and contractors, people from our own industry, we need to stop. And we have a solution. The laboratories who are represented here have solutions, but there must be a way to take it to the public. There's enough research going on. CBRA Roorkee, I know personally, have done a lot of research on this. And so there is no dearth of technology. There's no dearth of material. The equipment, there is no dearth of government trying to push it. But it is the consultants who have to specify this in the real practice. This is a problem which is going to be there, which is the adhered cement on the aggregates. So this is the Burari plant in Delhi. So we should proudly display our products like they do in Hong Kong and other cities. This is from Burari plant in Delhi. So there are a lot of success stories in India itself, but we need to have more of it. The Parliament building has used, CPWD have used in the Parliament building here. The Rosier road is functioning well. Pile heads is what we are trying to push. Enormous amount of piling is being done all across India, and pile heads are simply thrown around. I will skip on the other countries and sustainability. This is an important thing that we have to make sure that the energy that we have in the C&D aggregates is put to use. So this is the energy sustainability numbers of how much we pollute the atmosphere and how the recycled aggregates can reduce to a certain extent the pollution on the carbon emission from our systems. So there are a lot of benefits of recycling steel. We quite well know that, and now I think we should scientifically manage this. Otherwise, it can go in the wrong direction also. A few collapses of buildings using C&D waste will simply kill all the things that we have done so far. So with this, I will stop my talk, and I will say this is not the end. It's only a beginning of recycling. Thank you very much. Sorry, I've taken about 6 minutes extra. Thank you very much.
Thank you, sir, for your wonderful presentation. And you mentioned that C&D should not be called as a waste, but it is a resource. So I think it's a very good message that you have given to all of us. And you have also highlighted the importance of several such materials like RCA and RA, and several. Our next speaker will also highlight some of the works that they have been doing. I see Dr. Santa Kumar and others, those who have been doing work in the area of construction and demolition waste as a resource. Thank you very much, sir. Once again, Dr. Ashokan, should I move forward with your permission? Okay. I can't hear you, but yes, okay. Moving to the next, we have Mr. Deepak Bansal, who is the joint GM projects at HUDCO. I know him personally for the last almost 1.5 decades or 2 decades. He is also working in the area of embodied energy and embodied carbon. So this is how I am associated with him and his PhD. So over to you, Mr. Deepak, for your keynote on cross-sector waste recycling MSME perspectives.
Good morning, sir. Thank you, Dr. Ashok Kumar, and thank you, Dr. Ashokan Pappu, for inviting me and giving this wonderful forum to share the ideas on construction and waste recycling and uses of the same in construction industry. I'm not expert, and secondly, just a irrita that I am not still doctor. I'm still Mr. Deepak Bansal. So anyway, thanks a lot. Good morning to all esteemed speaker, guest, invitee, ladies and gentlemen. I'm practitioner who is into housing industry, so I know about the housing industry to some extent. This housing industry is highly unregulated. Here, more than 90% of buildings are, non-engineered. And they are being constructed, they are being demolished by the people themselves. So there is no much data available on their construction and demolition and their transportation to the landfill site and their reusage. What is my experience in this area is that what happens that people engage the subcontractor, and these subcontractor do the demolition by the screen is visible, so my screen is visible.
Yeah, visible, but you can put on full screen mode.
Right. Just a minute. Yeah. So
Yes.
So what I believe, what I've seen in the building industry, that normally while demolishing the buildings, people involve petty contractors, and these petty contractors salvage lot of materials from the buildings, like bricks, steel, electrical conduits, electrical wires, and they process it in the neighborhood itself, and they give some value to the people. So these are not having any negative value, but they in fact give some value to the people who are doing this. The problem in construction and demolition waste collection, segregations, recycling, and reuse is that first of all they have to be transported a lot of distances, and then the acceptability of the people using it is sometimes less. So this Burari plant, which has been mentioned earlier, and in fact, as per my knowledge, the first C&D waste recycling plant was established near Mumbai. But still their outputs and their performance is not up to the mark because of many factors. And first of all is the acceptability, and second is the awareness. Most of the people are not aware that these products are conforming to Indian standards, and IS 383 has recognized uses of manufactured sand and manufactured aggregate to certain percentage in the concrete and construction. So people are not aware. Secondly, how to get the desired materials, because there is a question of performance of these materials and transportations and cost involved also. But with the scarcity of sand and aggregate in the country, now these sand and aggregates are not available at very affordable prices in many cities in India. So people are forced. So people are trying to find out. So this is a big opportunity for the industry to recycle and reuse the construction and demolition waste in the construction of buildings. Because I'm from building sector, so I know a little bit about building more compared to other infrastructure work. So my presentation will be based on that. And secondly is the embodied energy. Of course, that when we are using the product, then embodied energy of these products is less, and thus the sustainability of the built environment using these materials will be much more. So we all know that more than 40% of total solid waste material generated worldwide as construction and demolition waste. Several countries are struggling to reduce, recycle, and reduce these construction and demolition waste. In fact, while doing some research over the buildings in Brazil, I came to know that there 25% of total material used in construction of new building turned up into waste. So this 25% is a huge number, huge number. Even in Indian condition, when we see the analysis of rate masonry, then we find that still this approximately 500 numbers of bricks are used in making 1 cubic meter of brickwork. Practically, if we multiply the volume, then it comes out to be roughly 425, 430. So even 10% of that will not be more than 460. But 500. Why is 500? Because we believe that either pilferage or wastage of these materials is much more. So this can be, effectively reduced by doing this proper implementation, transportations, and construction system, so that the material wastage is reduced. So ultimately, the construction and demolition and leftover of the construction will be less. So presently, what is happening then? Construction and demolition waste are mixed with other solid waste and disposed on landfills. So these are, increasing the load on landfills, and these are, mostly inorganic materials which do not decompose. So they increases the volume of the landfill and make landfill unsustainable. Generally, construction and demolition waste comprises of concrete, bricks, timber, sanitary ware, glass, steel, and plastic. And we know from the previous presentation that the most of the construction and demolition waste are brick blocks and soil and concrete. Delhi generate about something like 6,000 metric ton of municipal solid waste, which is too high. So waste to health, we can reduce the waste, we can recover it, and we can recycle it. Generally, the present status of solid waste disposal is that either they lie on the site simply, or they are dumped in the open, although this is not allowed. They are sent to landfill sites, or they are dumped on the eco-fragile zones like riverbeds, water bodies, so which further contaminate the environment. Now, the different researchers have given the volume of construction and demolition waste As new construction, somebody says that 5 to 25%. Repair and renovation, somebody says that 10 to 25, 30%. And major part of the construction and demolition waste come from demolition of the buildings. But the traditional knowledge which is available in the Indian building industry is that to recycle it using the local people, so that, like in Ahmedabad, what is happening? That in the pole, all the heritage features in the buildings like balustrade, like railings, like doors, like window members are being recycled and sold. And they are fetching much good value, and they reduces the loads on the construction and demolition sites. The percentage of solid waste has already been discussed in the previous slides. So as I believe that reduction of construction and demolition waste can be done by efficient planning of the construction, that if we can reduce the wastage and pilferage of the materials like bricks, soil, sand, aggregates, the steel. Normally the percentage of wastage in steel is 2%, but in bricks, soil, sand, aggregates is 5 to 25%. Now the Indian code has allowed replacement of natural sand with the manufactured sand up to certain percentage, depending upon the qualities. The same is for coarse aggregate also. Now I have come across that, that some people in Ahmedabad and Maharashtra are making surkhi bricks. That what they are doing, that they are taking the crushed brick powder and sand and aggregate and putting some lime, gypsum or cement in that and making the bricks. The performance of these surkhi bricks, although these are not much known outside, but the performance of these surkhi bricks is much better. The crushing strength generally is about 50 kg per centimeter square, which is the dry crushing strength. And the water absorption, the weathering, the toughness, the surface finish are also good. The replacement of virgin steel with the recycled steel is also now prevalent. That I believe that steel industries are recycling 10 to 30, 40% of steel in making the new steel. So this reduces the consumptions of raw materials, as well as they are reducing the cost and embodied energy of the new products. The performance of this steel can be made as per the desired level. The construction and demolition waste are also a very good substitute for good earth. Normally, good earth is required under the road, under the embankments, in the plinth filling in buildings, and in raising the ground in flood prone areas. So the construction and demolition, and these are inert material. So they don't react with the soil water, they don't react with the soils, they don't leach the groundwater. Some new products which is being used, and we have also been my personal level, I have used this product from other waste, not the construction and demolish waste, but sometimes this agriculture waste also. I've used the sugarcane bagasse ash bricks in Nagpur. VNIT Nagpur is doing good research on that topic. The brick from rice husk, bricks from red mud has already been experimented a lot, and have been used partly where the raw materials like bauxite mines or iron mills are there. Recently, I come across that from the municipal waste, this sludge and this pulp and paper waste has been used to make the bricks. The IIT Guwahati has done some work on this topic, and they are in the process of making the recommending Indian standard on that. The performance of the brick made from this municipal semi-solid waste is found to be good. Bricks and partition panels from phosphogypsum has been used since long. The construction and demolition waste are largely being used for making the tiles, and they are very good in that. But the trouble is that people, I mean, this is my personal level experience, that people are not very comfortable in using that. I do not know why, because the performance by these products is much better, but probably because of limited supply or limited source or locations. So maybe transportations or logistic may be an issue. So people are not but using it the way they should have been used by now. So the issues which are hampering usage of product made from a solid construction demolition waste are acceptability. Like when this fly ash was being used to make the fly ash bricks, blocks, then people were very hesitant that this is that, we are making bricks from ash. So what is the, performance or what is the, characteristic of that brick or block making from fly ash? So it took long time. Secondly, to partially some extent, the people were people were right because the quality of fly ash which were given to brick or block manufacturer was not good because the good quality fly ash is being taken by a cement lobby. So sometime what happened that some people because they got some plant is commissioned there, so they took some
Mr. Deepak, can you conclude because the time is short, so maybe
Yes,
you can
yes,
go to
yes,
your
yes. So
conclusion.
logistic, costing,
Thank you.
specification, SOR and tenders are also, need to be developed to, promote the usage of these materials. So my take on this thing that waste has to be generated at source and small decentralized plant like this has been mentioned earlier that, mobile plants has to be established so that cost of, transportations to and fro. Development of standard codes, SOR, and on-site testing has to be there so that people can have confidence on these materials. So that's all from my side. Thank you for giving me this opportunity.
Thank you, Mr. Deepak Bansal, for your wonderful lecture. And you highlighted the importance of waste recycling. And I'm sure there will be some questions at the end, which will be taken up maybe at the end of the session. Dr. Ashokan, is there anything for me or should I go ahead? Okay. Ladies and gentlemen, as we are already short of time, we are late by about 10 minutes. So moving on to the next speaker, Dr. Anjan Ray, who is the Director, CSIR, Indian Institute of Petroleum, Dehradun, and also he's also having the additional charge of CSIR, Central Building Research Institute, Roorkee. And he needs no introduction, but I'm sure the talk which he is going to deliver will definitely set a tone or target for sustainability and rules for sustainability and how we can handle these waste from circularity point of view and others. So without taking much time, over to you, sir. Thank you. Namaskar.
Thank you, Dr. Ashok. Very good morning to everyone. I will start by thanking Dr. Anandavalli, Mr. Mohan Ramanathan, and Mr. Deepak Bansal for setting this coming session in context, because the understanding of waste to wealth is not very well developed here in India at this time. And what I will try to do in the next 7 or 8 minutes, keeping our time constraints in mind, is give you a perspective on why what we do is so important. Very simply, sustainability is about meeting the needs of the present without compromising the needs of the future. And we have not done very well as a planet. 60% of the vertebrates that were there in my childhood in terms of species are gone. And the two basic rules that we should not harvest things beyond the regenerative capacity, and we should not deplete non-renewable resources without substitution, have not been well maintained so far. These are very simple rules. If we keep them on our wall, as I do, and every morning you look and see whether all the work that we do is aligning to these, you can actually get a more sustainable planet. The core issue is overconsumption. Whatever the earth needs versus whatever is actually extracted is poorly balanced. So, you can ask the question, does anybody need 29 pairs of shoes or 30 shirts? And then you start seeing that maybe the answer is no. But for everything that you overconsume, there's an overconsumption load on the 4 basic natural resource blocks that the world deals with. And in 250 years of progress, we can see that every parameter has gone up. So as we have measured GDP progress, we have also extracted resources well beyond what the earth can sustain. So if I look at this from an Indian imperative, and I use this phrase resource efficiency, which I encourage all practitioners of wealth to waste to examine, it's simple mathematics. Can I get more output from less resources or more output from given resources? And that is where all the work that's been talked about this morning and all the 4 technology presentations that will follow me will focus. But as we measure the resource efficiency, we will be able to choose which technologies are better and which ones are worse. For example, when we do crushing, it's a good thing that we're recycling. But if I'm using a lot of fossil energy for that crushing, then maybe we need to re-examine that part of the recycling value chain. We've talked about these 4 basic material resource categories. Today, we are mostly in the non-metallic block. But with things like red mud, we might also be in the metallic block. We should remember where we are in terms of our achievements. And also keep measuring at all times how we are doing against these metrics. In particular, the abiotic resources are not used for energy consumption. And also for everything we are doing on the resource recycling, reuse, etc. side, we might be consuming water and other things that we must be attentive to, because we should not create another problem while solving one problem. Another interesting issue is that when we overconsume, no matter how we overconsume, we overuse machines. So in a very simplistic way, we can say that machines enhance greenhouse gas emissions because no machine is 100% efficient. We've learned from class 7 physics that all machines have less than 100% efficiency. Therefore, in theory, a lubricant is a fighter against climate change. Does every machine, including construction machinery, demolition machinery, JCBs, hammer mills, are we using the best lubricant? That itself is an important consideration for managing the footprint of our emissions. These are the things that I would like to draw your attention to. What we heard from Dr. Anandavalli was about resource efficient recycling. She gave the example of red mud. What we see in the building industry is we've moved away from buildings that look nice. You know, they're all glass fronted, sun facing. Today, we first look at functionality. How do I make the building functional? Then we look at adaptive aesthetics. We have moved from thinking of buildings and communities as energy hogs to thinking of them as energy generators. Planting trees, not only for landscaping, but actually for sequestering carbon. And like I mentioned, renewable energy to drive machinery and using bulk inert inorganic wastes, not so much in landfills, but as carbon capture reactants. If we are able to achieve all these different things that we're talking about and foresee a future where we not only reduce, reuse, and recycle, but we do so responsibly and in a resource efficient manner. So I'm adding 2 R's to those. We could potentially leave behind a more sustainable world than the one our generation has inherited. Saying that, we will recognize that sustainability is an imperative, it is not an option. And if we start thinking of wastes as underutilized resources rather than wastes, we get a better position on sustainability. We also need disruptive thinking. Only incremental thinking will not get us there. With this, let me thank you all, and I wish the iConnect events and this particular Icen 44 event much success, and thank the organizers once again for inviting me.
Thank you, sir. Thank you very much for your wonderful ideas on highlighting the importance of resource efficiency, and very nicely you have highlighted the changing paradigms and disruptive decarbonization where the trends are gathering these days. And you said at the end that sustainability to be considered as an imperative, not as an option. So thank you very much, sir, for your wonderful thoughts on this particular topic. Namaskar. Ashokan, now what else? Should I move forward? Okay, I am not able to hear you. Okay. Moving. Yes, sir.
I was saying let us continue the session.
Okay, sir. Okay, right, sir. Right. Thank you, sir. Moving to our next speakers of the session, we have technology presentations by different speakers. So on the list, the first speaker is Dr. A.K. Sinha, who is the senior principal scientist at CSIR Central Road Research Institute, New Delhi, and his talk is on utilization of copper slag for road construction. I think let us welcome Dr. A.K. Sinha for his talk, please.
Thank you, Dr. Ashok Kumar ji. I am audible?
Yes, you are audible, but your screen is yet to be visible. So it is taking time. So just hold on for a while. Yeah, you can. Yes. So
it is also
screen.
moving?
Thank you. Yes.
Okay. So
it's moving.
Thank you for invitation. And we can say good morning to everybody. Myself, Sinha from CRRI. And we will discuss here regarding copper slag waste materials for road construction with CRRI experiences. So in this copper slag, CRRI has studies in the laboratory also, and a pilot study was carried out. So in detail, geotechnical parameters pertaining to road construction and a pilot study with performance study, we will present in this presentation. So copper slag is waste material. It is generated from copper industries during extraction of copper metal from Australite Industries, Suti Korean, as well as from Hindalco Industries from Dahej. Copper slag was collected for feasibility study. There are two types of copper slag produced. First one is coarser materials and another one is finer materials. Depending upon the quenching during the extraction process, water quenching, and depending on the quenching process, both materials were generated. So if you will see, in one aspect, due to large infrastructure construction, soil aggregate materials are depleting, and we have to search for other alternative materials. On the other hand, we will see copper slag waste materials has potential for road construction as a road construction materials. And presently, it is partly utilized in road construction and partly simply dumped nearby the industries. And if you will see present, some of the barriers, challenges are persisting, which hinders the application of copper slag as a road construction materials. If you will see, there is no any proper guidelines as per MORTH guidelines, or even there is no any construction methodology. Performance durability regarding materials are not available in the documented. So these are the even lack of a skill is there, performance of engineering materials, lack of awareness, all are persisting, which hinders the application of copper slag materials. So broad sequence of studies was carried out in the laboratory as well as in the field also. So first of all, it was examined, it is a hazardous or non-hazardous material, and it was found that it is a non-hazardous material. And then engineering properties were determined as per the standard of procedures. And then accredited by the Indian Road Congress. And after that, a pilot study was carried out and 3 years performance was monitored, and based on that guidelines as per the IRC, it is under the development stage. So copper slag was studied as a embankment materials or as a subgrade materials without mixing with other materials or with stabilization, mechanically stabilized with soil or pond as a replacement of soil. So pertaining to road construction materials, in application of embankment or subgrade, these properties where grain size, liquid limit, plasticity index, dye density, free swelling index, CBR, shear strength parameters were determined pertaining for embankment and subgrade application. Whole methodology was bifurcated in 2 stages, laboratory studies and field studies. In laboratory studies, complete physical, chemical, geotechnical parameters were evaluated, and then to improve the properties mechanically and chemically was stabilized with cement or as a soil materials. And then after getting all parameters, design and stability analysis of embankment was carried out, and based on that, pilot study was carried out using copper slag as a embankment materials, and then economic analysis was carried out, and 3 years performance monitoring was carried out. So in physical and chemical analysis like SEM, XRD, all those things were carried out, and these are the SEM photographs, and this is a coarse grained materials. Similarly, geotechnical parameters were determined in the laboratory, and this is the grain size distribution curve of copper slag and pond ash and locally available material, and it is found that it is a sand size particles and has poorly graded materials. So it was blended with pond ash in different percentage from 25%, 50%, 75%, and it was found that after blending with pond ash, density is little bit reducing with the addition of pond ash. Copper slag was also blended with chemically with cement in different proportion, 3 to 9%, and it was found that UCS value is increasing with respect to during periods, with respect to cement content also. So these are the some of the properties of pond ash and copper slag collected from the Birla Copper Industries. A typical cross-section was designed for field construction, where the embankment was constructed using 50% copper slag and 50% pond ash. And this is the pictorial view of the designed cross-section. And based on that, a pilot study was carried out, and this is the salient feature of the project. Project was constructed at Tuticorin, Tamil Nadu, along the National Highway 45B, Madurai to Kanyakumari Expressways. At ROB, right side, copper slag was used as a embankment material, and the left of the ROB, embankment was constructed using conventional soil materials. Both approach 500 meter each side were used for the experimental test section. This is the existing site condition at left hand side, and this one is the right hand side before the construction of ROV approach road. So this is the copper slag stacked along the proposed alignment, and where existing road was 2-lane undivided road, and it was proposed to 4-lane divided roads. In one approach, if you will see, copper slag was stacked and then spreaded and rolled out, and this is, you will see fine one layer compacted is there. But what happened when loaded truck was ply on this for second layer, we will see under the wheel, copper slag was segregated under the wheel. So it means we have examined how it is possible technical parameters are pertaining to subgrade embankment material and subgrade also. But when as a practically it is not feasible. So to increase the cohesion between particles, it was decided that it will be blended with soil or pondous materials to increase the cohesion properties. So it was the for mixing of copper slag and locally available soil, different indigenous equipment like tractor tow disc, tractor tow fowler, and grader was also used for to know the efficacy of the mixing of the equipment. So it was found that tractor tow fowler is efficient and it is mixing properly. So this is the pictorial view of the copper slag mixed with pondus, which is the mixing operation, and after compaction, this is the pondus copper slag layers. And whole construction was constructed with copper slag and pondus. So this is the another. You see, it is a frictionless material. So what for protect the erosion of slope, locally available soil was used to protect the slope of the copper slag fly ash embankments. This is the existing ROB approach road. And during the construction, layer by layer, each layer density was measured, and it was found that it is coming more than 95% as per the IRC guidelines. During the construction, modulus of the embankment layer was also determined by using plate load test, and field CBR was also determined using DCPT test. And after the construction, whole construction, performance monitoring was carried out by measuring different parameters like roughness, deflection, and settlement. So this is the pictorial view of the constructed 4-lane divided road, and where in this section and in this section, copper slag was used as embankment material, and left path and middle and right path, both side up and down settlement was measured, and this is the pictorial view of the deflection measurement using my Beckelman beam. And this is the pictorial view of the tip stick measuring roughness parameters, and this is the roughness parameter respect to time, and here is another one. This is the deflection with respect to time periods, and it was found that copper slag embankments and the conventional material, conventional section both are behaving similarly. Here, settlement was measured time to time at middle, left, and right also. After whole construction and performance society, economic analysis was carried out with considering different parameters, and it was found that around rupees 2.75 lakhs can be saved for 2.5 meter high embankment construction. And now copper slag is being used as a road construction materials. This is a pictorial view of the copper slag application at widened portion at nearby the haze. And after that, here I received a Scotch Award in 18 based on this study. And if you will see from this conclusion, we can say copper slag essentially it should be blended with locally available soil or pondus for application in a embankment material or a subgrade material. Mixing by tractor to tiller is practicable and economical. Pondus needs to be laid first before copper slag layer, and deflection roughness parameters of copper slag embankment are similar to conventional sections, and it can be used as a embankment and subgrade materials. Already IRC SP 121 guidelines for use of iron, steel, and copper slag is developed only for rural roads, and for highway construction, it is under developed condition. So printing may be finalized in 2 or 3 months. Thank you for this. This is my presentation.
Thank you, Dr. Sinha, for your wonderful presentation. And I'm sure that this is one of the very good examples of research from lab to land. We always say that, how the technologies developed by scientists are being utilized in the land, in the field. So Dr. Sinha has very nicely given the example of a national highway, Madurai-Kanyakumari Expressway, and very appropriately mentioned about the usage of copper slag with pond ash and also soil. And one of the recommendations of his outcome is that the copper slag must be mixed with soil and pond ash we are using for both embankment and road construction. So thank you very much, Dr. Sinha, for your nice presentation, and we'll take up the questions at the end of this session with the permission of coordinator Dr. Ashokan Papu. Thank you. Now moving to the next speaker, Dr. J. Prabhakar, who is the Chief Scientist at CSIR Structural Engineering Research Center, Chennai, and who is going to deliver a talk on cost-effective, durable water tanks using flowable cement mortar. And yes, before that, there is a Mr. M.K. Gupta also. Is he available, Dr. Gupta?
Yes, sir, I'm available, sir.
Okay, sure. So before going to Jay Prabhakar, I was told that he's having some technical issues. So thank you, Dr. Gupta, for joining. Dr. Gupta, he's a scientist at CSIR Empri Bhopal, and who is going to deliver a talk on eco-friendly X-ray radiation shielding, lead-free red mud door and panels. Over to you, Dr. Manoj Gupta,
Thank you,
who is
sir.
the recipient of CSR Young Scientist Award 2020 in the area of physical sciences.
Thank you, sir.
Okay.
And first of all, I would like to thank the organizing committee for inviting me and to present my this work in this excellent forum today. Thank you and good morning to all of you. So today I'm going to present one of my developed technology, eco-friendly X-ray radiation shielding, lead-free red mud doors and panels. So I'm Dr. Manoj Gupta, working as a scientist at CSIR Empri. So in today's talk, I will cover the main aim and the problem addressed in the current technology. So in this work, what we have done, we have utilized the industrial inorganic waste to develop the radiation shielding panels. This is the alternate of the lead-free, lead-based doors and their products for the X-ray radiation shielding panels. And this also lead to avoid harmful disposal of the lead. And we are using the bauxite waste management and holistic approach to develop this product, and utilizing unexploited renewable natural fibers in this product. And this product is a new class of the thermal insulating, electrical insulating and high strength fungus and swelling free radiation shielding panels. And further technology commercializations and how to create new industry will be covered in the today lectures. So why this kind of the radiation shielding panel is required? This is the basic question. So as we know, in the hospital or medical sector, a lot of X-ray are using daily for treatment of the medical diseases, and unwanted exposure of high energy are like ionizing radiation such as X-ray or gamma rays, which is the electromagnetic radiation, are found to be hazardous to the human health in many ways. Also in the airport, we can see the X-ray screening gates and doors that used by the lead-based material. And these kind of the unnecessary exposures create a lot of the diseases in the human body. Like when X-ray hit any material, so it transmit, reflect, and scatter. So the scattering of this X-ray further goes to the Compton scattering effect. It create photoelectric effect that another make the secondary ions in the form of the secondary X-rays. So these kind of the secondary X-rays are photoelectric effect cause X-rays create many causes like thyroid glands. It also affect the lungs, internal bleeding, acute effect, skin burns. So many risks are involved in the X-ray radiations kind of the treatment. So we need to immediately find some kind of the material that must be lead free. So presently what is happening, we are using the lead. So why? Because it has a high atomic number, high density, and also having a good linear and mass attenuation factor. But it is very toxic and also very costly. And making these kind of the lead panels require high energy, high temperature process. And also when we use the lead panels now, so it is having a brittle nature. So after 1 year or 2 years, a lot of fractures created that again make the unnecessary exposure of the radiation. So every 2 years or 1 year, BARC or AERB must visit the respected X-ray room to validate whether this lead is working currently or it need to be replaced. So we need to find the alternate of the lead based panel. So like lead glasses or doors or apron, these are mainly based on the lead materials. Other materials are also available like tantalum, bismuth, tungsten. These kind of the material are also utilized to make the panels, but it is very costly and it is having the metallic nature. So other drawback, like as I told, ki sometime when two different kind of the metal oxide mix with the polymer materials, so it another required a proper mixing to have a better interfacing at a high temperature. A cement based concrete with a very thick volume is used to protect the X-ray, but it cannot be used as a door or panel purpose and also exhibit high water absorptions. Now, so with this aim, we have developed the X-ray radiation shielding doors and panel with a very less water absorptions and high strength capability. And we have measured the half value layer, that is primary requirement to validate the product is having X-ray radiation shielding property or not. And high tensile flexural strength with low thermal conductivity was obtained in our developed technology. So basically, to develop this technology and develop this product, we have utilized the red mud, which we all know it is a solid waste which produced in the process of the alumina generation from the bauxite waste. And more than 13 million tons of the red mud is generated from many industries like Nalco, Hindalco, Vedanta. And most of the red mud is having the more than 30 or 35% of the iron oxide. And once we produce the alumina from bauxite, we need 3 tons of the bauxite that produce 1.3 to 1.5 tons of the red mud and just 1 ton alumina. Means waste generation is very high, and like it is having a alarming issues always. For generally it is just disposing outside, and only few quantity is used in the cement or in the bricks. And like in the villages near the red mud generations, it has a lot of like diseases is also occurring like skin and lungs, whole body. So before producing our developed product, we have done the initial characterizations on the red mud. So we have did the X-ray diffraction and we found that it is having the hematite phase and gibbsite phases. And then we also did the WD X-ray fluorescence spectroscopy to find out the elemental analysis. we come to the conclusion that iron oxide is having 33.9%, then alumina oxide, titanium oxide, sodium oxide, and the particle size of this red mud was in the range of 0.5 to 150 micrometer, and it is having density of 1.2 to 1.8 gram per cc. And you can just see the water holding capacity is also more than 30 or 40%. It means once it is going to dispose in the open land, it can transfer the ions from soil to the water and also the like agricultural land, that create another problems. So after a lot of optimizations and surface modification of the red mud on the through the compression molding machine and other process, we have developed such kind of the blocks. You can see this is the size of the 10 centimeter by 10 centimeter, also 4 centimeter by 4 centimeter with the thickness of 1 mm, 2 mm, and 5 mm. We have developed this kind of the product, which is having a very less water absorption and high mechanical strength. So whether this product is having X-ray protection capability or not, we have performed the half value layer measurement at the King George Medical University. And you can see that this is the graph, like 1 mm, 2 mm, 4 mm, 6 mm, and 8 mm thickness of the red mud panels was used, and we have measured the charge. And once we can see that the half value layer is about just 4.9 mm, means this 4.9 mm is able to absorb the X-ray radiation by intensity of the 1/2 of the initial intensity of the radiations. And this is happening because of the presence of the iron oxide, titanium oxide, which is having the blind absorption coefficient near the X-ray absorption is. So this validation is done at the King George Medical University. And once we compare the value of the HVL with the lead concrete, we can just see there this is having just 4.9 mm. And in the case of the concrete and other thing, it is 15.10. It means about 10 mm to 12 mm thick lead red mud panel can protect full of the X-ray intensity with the energy of the 100 kilovolt. So this is quite very good result. So then other parameter, like if we are using other metal oxide which is having very high thermal conductivity, then scattering is another problem. When it interact with the X-ray with any metal, then different kind of the scattering occurs. So our material must be have a less thermal conductivity. So you just see that the thermal conductivity of the board is just in the range of the 0.55 watt per meter Kelvin, very less thermal conductivity. It means it is having thermal insulating properties. And also the dielectric constant, whether it is electrically polarizing or not. So just dielectric constant is only also very less, about just 50. Means polarization chances is also very poor. So it means better X-ray radiation shielding property. Most of the X-ray is going to absorb within the material without producing a lot of secondary X-rays. And the density we can reach up to the 1.8 gram per cc. Now to validate whether this kind of the iron oxide or titanium oxide is having such capability to protect the X-ray, we fabricated two panels, one with the marble waste, which is having the calcium rich phases, and one with the iron rich phases. So in the case of the marble waste panels, we don't get any kind of the HVL, means very less amount of the energy is going to dissipated. But in the case of the red mud, the energy is absorbed. It means this is the main reason of the iron. And now if we compare both the X-ray refraction pattern of the marble as well as red mud, so we can see in the case of the marble waste, this is having the dolomite phase or calcite phase, so which is not having the capability to absorb the X-ray. But here we can clearly see. Now, to practically utilize this product, we have signed the MOU with the King George Medical University, Lucknow, to test and validate the product at a real-time conditions. So we signed the MOU with the KGMU, and our product is also tested at different laboratory. And recently we also got the patent on this technology that is published online in US and other European countries. with the help of doctors team at KGMU. Now, the surface aesthetic property can also be like improved. Like red mud is having the reddish color. So if you want to have a better look, so different kind of the skins material can be utilized using the natural fiber. So the shape, texture, design, size, and thickness can be easily tuned to get the smart X-ray radiation shielding panels. And most important point, it is not having the brittle nature. No fracture can be occur after even 10 years. So we have done the weathering test also of this product in a different UV conditions, or like raining conditions, or in high temperature condition. And natural fiber can also be utilized to increase the tensile or compressive strength of the product. And another patent we also got in this area. Now we have successfully done the upscaling. Pilot scale production of this product we have done to perform the real-time testing at the X-ray room. So we can see that the size of the board is 2 meter by 1 meter and the thickness is 25 mm. So a full scale door is developed in our lab, and this door is having the water resistant property. It is purely eco-friendly and non-toxic materials, and strength is very high. No termite attack can be possible, so the brittleness and other fracture kind of the things is we can easily avoid. And it is having the thermal insulating property, chemical resistant. We have done the mechanical study even after pouring the product in the acid and alkaline media with as per the ASTM standard. And also electrical insulation property this board shows. So this is the product what we have developed in our lab. And since a lot of properties associated with this technology, like salient feature, low temperature fabrication process within 100 degrees centigrade temperature, we can develop this product. Otherwise lead is having more than 1000 or 900 degrees centigrade processing. Without joint free board we can develop ceramic free material, and this is having the polymer based board, so the thermal insulating property can be sustainable for a longer period of the time. And fire retardant properties it is having. It is highly suitable for the hospital and the X-ray room, and it is having a very economical and environmental friendly properties. Now, from very beginning, we have already collaborated with various kind of the industries and the other academia for technology transfer and the future commercialization of this product. And if we talk about the market price of this such kind of the board, so in the market we can get such kind of the lead based panel within the range of 1 lakhs to 1.6 lakh rupees per door, whereas our technology even at the lab, even at the laboratory scale, is having cost just 20 or 22,000 per board. So it is a very economical solution. Now to validate this product, we have developed the full scale radiation shielding board, and we have tested and installed this board at the King George Medical University for the real time testing and validation. We can see this is the sandwich panel of the red mud board, and this is fixed on some stand where when X-ray is passed, the detector is kept other side of the board, where the detector just detect how much X-ray is coming another side of the board. So the testing is in the process at a real time in the King George Medical University. And just we have along with our respected actor Avnish Kumar Srivastava and PPD, we have visited the King George Medical University to validate and demonstrate the radiation shielding door, which is made by the red mud. And this is the just media coverage how this is going to like a game changer technology for the medical purpose.
Dr. Gupta, please
and
conclude.
This is the uniqueness of the product. As I already discussed, it is a durable, high strength, corrosion free, fire retardant. And also in the mobile clinic, where X-rays can be installed. So our panel can be installed in such kind of the mobile clinic also. In airport also, we can see a lot of X-ray screening rooms are there. And still we are also working hard to publish some paper in such areas. So thank you, sir. Thank you all.
Thank you, Dr. Gupta, for your wonderful presentation and a really wonderful work on usage of red mud in developing radiation shielding panels. And congratulations to you and your team. Thank you. Ladies and gentlemen, now we are moving further. Now I like to invite Dr. J. Prabhakar, who is the Chief Scientist at CSIR SCRC Chennai, who is going to speak on cost-effective, durable water tanks using flowable cement mortar. Over to you, Dr. J. Prabhakar.
Thank you, Dr. Ashok Kumar. Am I audible?
Yes.
My slides are visible?
Yeah, please. Yeah.
Okay. Yeah. Very good morning to everybody. So I am going to discuss about the cost-effective durable water tank using a flowable cement mortar. As many of might be knowing that ferro cement is not the new one. It is a very old technology. In CSR SCRC Chennai, in 1970s, ferro cement products have been developed, and so many applications are there with the ferro cement product. Particularly I'm going to discuss about the water tanks. Water tank is made of this ferro cement product. This thickness of this water tank is 1 inch. It is only 1 inch, and it's made of cement mortar and reinforced with this weld mesh and chicken mesh. So the advantage of this ferro cement is it's a lightweight, and it's highly durable and strong. So as I said, this water tanks are now produced in the 1970s, which are just kept it in our campus. There were a lot of rains, and it was maintenance was not at all no address. Even though if you see that the products are very without any damage, it is in perfect manner. And even in those days in 1980s, our scientists have made a lot of efforts to transfer this technology through various building centers, particularly in the southern part of the India. This ferro cement water tank. Yeah. Am I audible? My slide is visible.
Yeah,
you are audible.
Slides are not moving.
Oh, no, I have not moved it. I am kept it in introduction stage itself.
Okay.
If you see that since I said it is a 25 mm thick, that is a 1 inch thick wall only. So therefore, we need a mason of artisan type to make this product in precise, uniform thickness. So in those days, availability of manpower is not the issue, and the affordability of raw materials is the difficulties. Now it is the reverse. Now we can able to afford the material, but getting the mason of precise artisan type, it is somewhat difficult. So considering the material aspects, as I said, is very strong, it's durable. So what we thought is, why not we simplify the process? See, the construction is the difficult one. So if you make the process to simplify, so that we can use the product in a better way. So that is what the things we have thought. So as I said, the objective is the development of methodology to construct thin water tank by modifying the cement mortar as a flowable to achieve the following benefits. One is to overcome the demand on the requirement of highly skilled person of artisan type, and second is to reduce the cost of the water tank. If you follow the traditional method of construction, the labor part itself, it is taking more than 70% of the cost of water tank, and 30% is the only the material aspect. So if we come out with the construction simplify the process technique, then we can substantially reduce the cost of the material. So for that, we have developed a mix with the, this is the cement composite, cement one part and fly ash, either you can go with the GGS or fly ash. We can say about 50% of the material used both as a supplementary material as well as a filler. And we used fine aggregate, and we also used viscosity modifying agent, so that we see that the consistency and the uniformity of the mix should not be disturbed. And here one main thing is we have to see that since we are making the composites into flowable form, so we see that there should not be any shrinkage, because it's a thin member. By making the composite into flowable form, we see that there should not be a crack formation. And also, since we are making the composite into flowable form, we are not compromised that strength. So in such a way that composites have been developed, and you can see here the same weld mesh and chicken mesh is used as a reinforcement, and we used two mold type. One is the inner mold and the male and female mold, and in between we have placed this reinforcement gauge, and with the suitable cover, we are simply you see here this picture showing this in a bucket, this cement flowable mortar is poured into the mold, and you can next day you can demold it. You will get this tank. So all properties, like deformation and this thing, stress and the strain and everything was measured by filling the water, full water, and we also even we can lift the water tank by through this four corner. You can say at the time of construction itself, we have fixed this hook. Through this hook, we have completely lifted the water tank, and we also measure the deformation and whatever the structural aspect point of view, all the measurements have been carried out. With that concept, we also gone with the prototype, a kind of water sump, having capacity of 10,000 liter capacity. So simply the same flowable motor was poured here, and you can see here this can be easily transported through a mobile crane, and it was installed, and it is running for the last 10 years in our campus. And people might be, this water tank we developed for the suppose we go for mousing, so there it is very much useful. So we can construct this water tank just as whatever I described. So simply you can with the crane help, you can keep it on the place wherever you are going to keep the water tank. But if you want to, suppose some people may ask, if individual person want to buy this water tank, whether it is feasible. So if you say it is not feasible, because for keeping this water tank for in any individual particular residence is costlier, because you need a crane to be engaged. So to overcome that one, we have come out with a precast thin segmental panels. So all this, in a water tank, there is a 4 sides and the bottom 1 side. So 5 panels are involved. So for 5 sides are there. What we did is we have come out with the joints. So you see here, this is a jointing system. So particularly in precast, leakage is the most important point. So we have developed this jointing system in such a way that if you pour here just by arranging this panel like this, and if you pour this concrete, so it will not allow the water to leak. So like that, we have developed this is a precast water tank. These all are separate panels. So you can see here, all these panels are separately cast, including bottommost, that bottom panel. And wherever you want to keep the water tank, there you can take this panel by carrying. This is very weight of the panel is only 45 kg, so that one person can carry to the terrace level, and it can be assembled. In the same day, you can pour water, you can use it, because the joints in such a way that it does not come in contact with the water. So you can pour the concrete at the joint, and the same day you can use it. That is the concept. And with the same small scale level we had developed, that was a 1,000 liter capacity. And this, in the same, considering the same principle, we also designed about 20,000 liter capacity. This tank we can also shift it from one place to one other place. In such a way, we are given a lifting arrangement also, so this can be can be shifted. The advantage of this one is it is very thin, and within no time you can, wherever you want to, suppose if a new construction is happening, so you want to store water and all, so you can just cast it at ground level and you can assemble it. That is a very cost effective. And even suppose somebody wants to have a septic tank, or they want to have a sump. Suppose then that will take, if you follow the traditional methodology, so it will take at least a month's time, minimum I'm talking about. But if you use this kind of methodology, so the same day, the tank will be, sump will be ready. That is the advantage. And it's a lot of saving is there, because in the particularly such kind of tanks, the shuttering is the most important cost involved. And also that is a major thing. Here there are no shuttering, because all the panels are cast at ground level. So you no need to have spend money towards that shuttering. So that is the beauty of this technology. So if we compare with this water tank with the traditionally available water tank in the market, like a Syntex tank, yeah. So I can conclude, actually this proposed our water tank is costing only 2,677. But whereas in all other water tank, if you say Syntex and all, heavy duty Syntex tanks, 8,000 rupees and all. And so these are the some of the things, we have tested. We have just lifted the complete water tank, and we have seen the any leakage is there or not. So all the studies we have gone through. And of course, it's a cost effective. It is also addressing the sustainability issue, because we are using 50% fly ash in this in the construction of this water tank. It's a lightweight because it's very thin. It's a 1 inch thick only. And of course, as I said, the thing we have modified the the construction methodology. Just you can, anybody can construct this water tank. You don't need require any highly skilled type person of artisan. So a lot of advantages are there. It can be shifted from one place to other place. It is easy to erect, and it also, it can magnify the this construction thing from 1,000 liter to 10,000. Even we can keep adding the modular panel. You can get the capacity you want. So it is a replacement to the plastic tank available in the market. So this technology is already transferred to one industry in Hyderabad. And mainly this is very good for the societal need, where the water is to be stored in better way. So this is that's all about this technology. Thank you very much.
Thank you, Dr. for wonderful presentation, highlighting the importance of your thin-walled water tank by modifying the cement mortar as a flowable material to achieve the properties. And as you mentioned that, this can be scaled up from 1,000 liter to 10,000 liters, and the precast panel can also be used for making these water tanks at site as well as the factory level. And thank you very much for your wonderful presentation again. Moving to the next speaker, Dr. G. Shantakumar. I think, yes, he is available.
Yes, sir.
He is the senior scientist at CSIR CBRI Roorkee, and he's going to make a presentation on making building components from construction and demolition wastes. As I mentioned in the opening remarks, that we at CBRI have utilized several materials of C&D waste, including pavement blocks and building blocks in one of the buildings, and construction and demo park at CBRI. And I'm sure Dr. Shantak is going to highlight some of those in his lecture. Over to you, Dr. Shantakumar.
Yes, thank you, sir.
Sir, a slide has been shared from here from CSIR MP. Please go ahead, sir.
Hello,
I am
Sharda
audible,
Kumar,
sir?
please carry. Yeah, you are audible. Please carry on.
Yes, sir. Yeah, thank you, sir. Thank you, sir. So, good morning to one and all present here. The topic of the today presentation is the construction and demolition waste as raw materials for making building components. Please go to the next slide. Yeah, the increasing generation and disposal of, as we all know, the increasing generation and disposal of construction demolition waste has become a strategic issue these days due to drastic growth of urbanization and industrialization. However, the disposal of construction demolition waste causes a severe ecological and environmental issues, and it is obviously essential to intervene and find other solutions than waste disposal. Meanwhile, the overall consumption of the natural aggregates is quite high due to tremendous consumption of concrete as well as mortar. So the overall high consumption of the natural aggregates causes huge pressure on ecosystems, as we all generally know. So, however, the worldwide availability of construction and demolition waste results in an outlet of recycle aggregates that we generally call it as alternative aggregates for making concrete and mortar. And therefore, the need to utilize those such aggregates, that is recycled aggregates, is becoming more important than ever before due to economical and environmental implications related to dwindling availability of natural aggregates and disposal of C&D waste, that is construction demolition waste. So then go to the next slide. So as the keynote speaker and planetary keynote speaker has covered almost all the basic introduction of those C&D wastes and their production process. So I just want to go to the directly to the technical. I just like to discuss more about the technical aspects. Can you go ahead? Next slide. Next slide. As these topics that are covered by that keynote speaker. Next slide. Next slide. Yeah. So, as we already know, concrete waste and the masonry waste should be major portion of the construction and demolition waste, as we generally know that. Generally, that recycled aggregates extracted based on as waste and other demolition waste is generally called as recycled aggregates. The is usually porous material and usually have high water absorption capacity and low specific gravity. Generally, the existence of the cement paste in recycled concrete aggregates generally forms a weak, porous, and cracky layer. And it usually have the poor grading aggregates. If we use the number of crushers, suppose it's the grading which mainly influenced by the what type of crushers that we can prefer for that. If we use the laboratory J crusher, then it will be, we can get the grading. If we use like that commercialized crushers like jaw crusher, impact crusher, jaw crusher, and cone crusher, then in such case we can improve the grading process. Now, and also IS 383 already suggests that it is suggested to utilize those recycle aggregates 100% in concrete for making the lean concrete. But it is suggested only to use 20 to 25% for making the plain concrete, plain cement concrete, as well as the reinforced cement concrete. So our motto is to use 100% of the recycled concrete aggregates for making the structural concrete. So in these aspects, in CBRI, we are working on in last 1 decade. Let's go to next slide. Next slide. Yeah. So these are the constraints. Just go. Yeah. These are the constraints that we are facing now. This lack of codes, specifications, and guidelines, lack of experience and awareness, and lack of mixed design in making the particular grade of the concrete. Actually, and also some of the technologies issues that we are generally facing when using the recycled aggregates while making the concrete or the mortar, structural mortar. So first one is that mortar, the first issue is the mortar or cement paste attached to the aggregate. Second is the poor grading. Third is that high porosity of the recycled aggregates. Fourth is the weak interfacial transit zone. Actually, whenever we prepare the recycled aggregate concrete, it usually have the two ITZ. As we all know, the one ITZ is between the new cement paste and the old cement paste. That is the weakest zone. That is the weakest linked property of the both mechanical and the durability performance. And other ITZ is that old cement paste and the natural aggregates. When we talk about, and also you see there is a variation in quality of the both the recycled concrete aggregate, particularly that was influenced by the strength of the parent concrete and the exposure of the parent concrete. As we all know, when the recycled aggregate extracted from the high strength concrete, it is obviously that it is very poor because more amount of aggregate cement paste was present on those aggregates. Then that extracted from the low strength concrete. That means aggregate extracted from low strength concrete, that quality of the aggregate is somewhat better than that extract. Now, these are the issues that we faced when we are using those alternative aggregates in concrete. Go next slide. So keeping these aspects, we have focused particularly in various building products, that is value-added building products such as flooring tiles, paver blocks, and that we have developed at CSC or CBI. I will come to the later how we have developed that those building products meets the requirements of the specific IS standards. Then we have developed various grade of concrete from M20 to M45, and we have studied the fresh properties and mechanical properties of using both 100% of the recycled coarse aggregate and recycled fine aggregates in aggregates, and those performances were studied in detail. And we have used various cementitious binder for making the recycled aggregate concrete. And the microstructure of recycled aggregate and recycled aggregate concrete, that is particularly ITZ and interfacial band, under the effect of the cementitious binders and under the new cement paste that we have studied with the help of SEM and petrography, and the properties of the mortar, that mortar that has requirements of the joint material as well as the matrix as used for the concrete, that we have analyzed separately, and we have studied those properties in detailed manner. Then go to the next slide. Next slide. Okay, and apart from that, some other, I think you have crossed your 2 slides. Go to the previous slide. Yeah, and also we have studied structural behavior of reinforced concrete made with the recycled aggregates and the static loading, and we have proposed various methods to quantify the amount of the adverse cement paste to identify the quality. Actually, the quality which is mainly influenced by the quantity and the quality of the cement paste present on the surface of the aggregates. I will come to the treatment process in coming slides. Then various treatment methodologies also have been proposed to improve the quality of aggregates, and the properties of the bricks made with the recycled powder. That is generally whenever we are making the recycled aggregates, more than 10 to 20%, that is a byproduct which will be coming from the recycled aggregate. That material also that were used, that was less than 75 micron, that we are used for making the bricks. And also we have used the CND waste. We have developed various products like CND waste, based pervious concrete, self-compacting concrete, and permeable film. Just go to the next slide. Yeah. So coming to this, the approaches for the CND waste treatment, as I have told earlier, so we have majorly the 2 types of aggregates. One is recycled concrete aggregate and the recycled masonry aggregate. Both aggregates are considerably the porous material. So actually porous material. Particularly in recycled concrete aggregate, this adverse cement paste, presence of the adverse cement paste was the major issue. And also, what is the other major issue is it will be in wide quality. The quality of the recycled aggregate may be different variably. So it is always suggested to adopt the treatment process for improving the quality. Suppose in CBRA, we have developed various treatment, we have proposed various treatment process, that is thermochemical treatment, chemical treatment, thermal treatment, and mechanical treatment, and various treatments were proposed to improve the quality of aggregates. But in commercial aspects, and also we have proposed the mixing sequences and use of the high volume admixtures along with the cost-effective additives. These mixing and sequences and those use of high volume, actually generally, whenever we use the recycled aggregates into the concrete, it has the tendency to develop the microfaults inside the concrete. So it causes a major drawback for both mechanical and durability properties. So one of the the solution is to increase the filling material by using those admixtures and other cost-effective additives. And also, we have developed some mixing sequences to considerably varying with the different recycle aggregate consistency along with their modern performances. So from that, we have developed the mixing sequences for making the recycle aggregate concrete to attain the desirable performance. Go to the next slide. So the methods that we generally adopt, which is mainly depends on the quantity and the quality of the cement paste present. So then these are the paver blocks that we have developed from that C&D waste, and these blocks can be recommended for the medium traffic purpose, as these are satisfying the minimum strength requirements of M40 grade. This we have developed the 100% of both recycled concrete coarse aggregates and recycled concrete fine aggregates. Let's go to the next slide. Yes, these are the various building products that were developed, such as bricks, blocks, tiles, and other self-compacting concrete, different grade of self-compacting concrete. After adopting the treatment process, then we have developed the various building products and those materials that meets the requirements of the highest standards. We'll go to the next slide. So these are the field implementation at CSIR CBRA. As the 20 already that our sir is mentioned that the 20,000 paver block of size 200 mm, 160 to 80 mm have been casted using the recycled aggregates and used in the payment of mass housing site demonstration park at CBRA. And also the C&D waste blocks are also used for making the wall at demonstration park. Go to the next slide. Coming out of this, we have successfully transferred that technology, that is process know how to develop the paver blocks and other building components from the construction and demolition waste. This technology has been transferred to the Hillside Eclog pavers. Go to the next slide. Yeah, thank you. If you have any questions, you can ask.
Thank you, Dr. Shantakumar, for your wonderful presentation highlighting the usage of construction and demolition waste into development of value-added building products. You have indeed highlighted the products that have been developed by CSIR, CBRI, and also demonstrated in construction and demonstration technology park at CSIR, CBRA, Roorkee. So thank you once again. Now, moving to the last speaker, Dr. Kirti Soni, who is the principal scientist at CSIR Entry Bhopal. She's going to speak on Empri's marketable technologies. Over to you, Kirti.
Thank you, sir. Thank you for giving me the opportunity to present our lab marketable technology. Advanced Material and Process Research Institute, AMPRI in Bhopal is an engineering material institute, is working under the umbrella of CSIR. As per the vision and mission of CSR AMPRI, we are working in the following thrust areas: lightweight materials, metallic materials, nano materials, smart and functional materials, and different type of composite material from the waste that is developed from the waste. And we are, in addition to these, we are also working in additive manufacturing and electromagnetic forming and artificial intelligence, and along with this we are also working in water resource management and rural technology development. These are the marketable technologies. These are licensed technology that CSR AMPRI has been developed in different types of different themes of CSIR. All these technologies has been licensed, and these technologies are useful for the employment generation and for the protection of environment. One by one we will see all these technologies. Under the Government of India Make in India program, CSR AMPRI has developed with the public and private leadership Raman spectrometer. This is an international standard spectrometer which having these features, and this can be utilized in different types of various applications. This equipment has been developed under the New Millennium Indian Technology Leadership Initiative. The two models has been developed that are available in the market. The first model is CTR 300 Raman spectrometer, and next is the CTR 150 Raman spectrometers. All these two models are available in the market and work and contributing under the 5 pillars of Atmanirbhar Bharat Abhiyan: economy, system, infrastructure, demography, and demand. Our industry partner recently received 2 orders on this product, and many others are in pipeline. Waste to Wealth is one of the nine scientific mission of Prime Minister's Science, Technology and Innovation Advisory Council. CSR AMPRI has worked a lot on the conversion of different type of waste materials such as fly ash, marble waste, and other type of waste material, stable paralis, etc., to make in useful product and employment generation. This is the first technology that has been developed by CSR AMPRI, and for this technology CSR AMPRI achieved the NIDC Innovation Award 2020. In this technology, CSR AMPRI has been utilized the waste material, that is the red mud. By using red mud, CSR AMPRI converted this waste into the X-ray radiation shielding tiles. These are the joint-free tiles, and this technology know-how has been transferred to Prism Johnson, and this is the unique technology that has been developed that can be utilized for in different types of applications such as X-ray diagnostic centers, hospitals, clinics, and all. By using this technology, we can protect our public and different environment from the harmful X-ray, gamma rays, and beta rays radiation. This technology is also available in the soon will be available in the market and has been transferred to the Prism Johnson. Parali burning, to address the issue of parali burning over Delhi, NCR, Punjab, Haryana, and UP, CSR AMPRI has developed an unique process that is capable for the conversion of parali in useful product. And by using this process, we can develop the employment, and we can convert this parali into different type of useful product that can be utilized for the building materials and other applications. By using this technology, we can contribute in waste management and environmental protection. This technology has also been licensed. Next is the next is the wood substitute that CSR AMPRI has been developed using the mining and industrial waste. This is the wood substitute is stronger than teak wood, timber, and synthetic wood, and this is resistant to moisture and termite and fungus. And we can use by using this technology, we can also generate the employment and save the environment also. In this series, next is the high performance hybrid green composite wood that has been developed by CSR AMPRI, and this is also the unique technology, and this is the cheaper than teak wood and better quality composite material that can be utilized for the doors, walls, partition panels, and roofing sheet and furniture, and many other applications. In this series, next technology that has been developed by CSR AMPRI, that is from the fly ash. This is the fly ash based technology and 4 times stronger than the teak wood, and about 30% cheaper than the teak wood, and durable and weather resistant. This technology has been licensed and can be utilized for the housing sector, civil infrastructure sector, transport sector, startup, can be utilized as a startup industries and makeshift building companies. Next, that is geopolymer concrete that is developed from the fly ash based advanced cement free concrete material that can be that is the replacement of cement. And by using this technology, we can reduce the carbon dioxide emission, and we can use this technology for the road. And by using this concrete, we can develop high compressive strength pavers block. These are the properties of this unique fly ash based concrete, cement free concrete. Next is the radiation shielding concrete that is developed for the gamma radiation shielding. This technology can be utilized for the nuclear power plants, bunkers for the strategic sector, and medical diagnostic installation. This concrete has been developed using the red mud, and this radiation shielding materials has been tested in BARC, and these are the salient features of this technology. Next is the advanced pavers block from copper tailings. Copper tailing is the waste material that has been utilized in this the development of a pavers block. These are the different engineering properties of the pavers block. By using the copper tailings, the pavers block has been developed. Natural fibers are also utilized in the useful materials, and in this series we have utilized the bamboo composite material, a unique process, and the composition has been developed by CSR AMPRI. Bamboo is by using the bamboo unique composition of bamboo, a lightweight, high strength, weather resistant, and eco-friendly composite material can be developed, and that material can be utilized for the different type of applications for construction industry, housing sector, and for the employment generation can also be used. And this is the unique process that has been developed by CSR AMPRI, and this know-how has also been transferred to industry. Next is the process that has also been developed by using the natural fiber, that is the sisal, and this know-how is utilized for the development of employment and different type of handicraft material, and textile industry, automobile industry. This sisal fiber can also be utilized by using the high tensile strength properties and bright color and high durability of sisal fiber. This technology is unique for the generation of employment, and this know-how has been transferred to Panchayat and Rural Development Department, Government of West Bengal, Kolkata. Safe water is the backbone of healthy economy, and in India, as per WHO, there are different parts of country where fluoride and arsenic harmful components are present in the water. So to overcome this problem, CSR AMPRI has developed some unique process for the water filtration. This is the number one technology that has been developed by CSR AMPRI, in which we have used the nano absorbent based filter has been designed in this, and this is the electricity free and gravity based technology that can be utilized for the filtration of excess of fluoride. Another technology that has been know-how has been developed by CSR AMPRI, that is for the arsenic, fluoride and microorganism filtration, and this is also electricity free and can be can be utilized for the different areas, and to remove the harmful components from in the water. CSR AMPRI has also developed a nano alumina based absorbent water filter for the arsenic and fluoride remover, and that our know-how can remove the fluoride and arsenic, and it is easy to maintain, easy for maintenance. No electricity input is required here, and by using this technology we can save the water, and this is as per the BIS. This technology is developed as per the BIS standard, and this technology, all these water based technology has also been licensed. As despite of being an engineering material laboratory, CSR AMPRI has worked hard during the pandemic situation and developed some unique process. In these processes technology, first is the makeshift hospitals that has been developed by CSR, jointly developed by CSR AMPRI and CSIR CBRI Roorkee. This is the unique special structure that has been developed, and by using this structure CSR AMPRI has been completed 2 makeshift clinic during the pandemic situation. First is the fever clinic at Government JP Hospital Bhopal, funded by the MPCST Bhopal, and another fever clinic in Devas that is funded by the Department of Health District and Devas. This is the unique technology that can be this structure can be erected by semi-skilled manpower, can be shifted anywhere, and we can make it easily, and as per all weather this structure we can design, and this is recently we have also completed using this technology makeshift hospital at Nandurbar, Maharashtra. This is funded by the Bill Melinda Gates Foundation, and soon we are going to make a hospital at Jhabua district of Madhya Pradesh. This is also funded by the Bill Melinda Gates Foundation. In the healthcare, another device that is developed by CSR AMPRI is the hypochlorite generator. This is a device that is using the simple, easily available water and kitchen salt, and by using a charger we can generate the hypochlorite, that is disinfected solution that can be used to clean the surface and make them free from virus and bacteria.
Dr.
Another
Kirti, yeah, Dr. Kirti, can you hear me? Can you wind up? Can you quickly finish, because we are only running short of time.
Yes, sir. Yes, sir. Next technology that is developed by CSMPRI is the hand sanitizer, and for the skin, for the enhanced skin care, this technology is developed by using the aloe vera gel and other useful materials that can kills the 99% germs, and this is also confirmed by the NABL accredited lab. And this is the face mask that is developed by AMPRI during the pandemic situation. And this is the AMPRI Care disinfected box. By using this device, we can disinfect the different types of stationary items, mobiles, and other gadgets and other items. And this is energy efficient, automatically disconnect when doors are open, and it is easy for installation and maintenance, and it is in compact size. This technology is also being licensed. And another that is developed by that is the lightweight material. This is developed by CSR AMPRI using the aluminum silicon alloy SiC composite material, that is the main hole cover, but which is developed, which is 67% weight reduction in comparison to cast iron. It is a very low in weight and can be utilized it is the replacement of cast iron and have the comparable strength as per the according to the cast iron. These are the different areas in which CSR AMPRI is working. If any industry and organization are interested and want to work in these areas, then we can work in collaboration, and you can approach at our lab. Thank you so much, sir.
Thank you, Dr. Kirti, for highlighting the technologies developed by CSR AMPRI Bhopal. Grateful to Dr. Avinash Kumar Srivastava, Director CSR AMPRI, for sharing all these technologies, information. Ladies and gentlemen, we are really short of time, and we can take one or two questions. Dr. Amit Chatterjee is there. Can you hear me, Dr. Amit?
Good afternoon, everybody.
Yeah.
Good afternoon.
Yeah, good afternoon.
Yes.
Please,
Good afternoon, sir.
Yes.
share your questions. Yeah, please. If you have any questions, please
I had one question regarding the utilization of red mud as a what you call it, radiation shielding tile. It's a fantastic work, highly innovative, and the way the problem has been resolved, the details have been shared. I really appreciate that. It's a great effort. So I hope that industry will be able to take it further forward. There are issues like how big the market for this radiation shielding tile as compared to the quantity which is generated for the red mud in the aluminium industry. So these are certain aspects. Maybe from industry side we should do a homework and exercise to find out, and then put a proposal before you to take it further forward. And what I expect from this iConnect, because I also participated in an iConnect event organized by IMMT Bhubaneswar, with whom we are substantially collaborating in 2-3 areas. We are working very close to each other. What we should take, that couple of areas we should identify, and then we have interest in the utilization of red mud, in the utilization of fly ash for the value recovery. So those 1 or 2 areas where we are deeply interested. we should make a program, and we should organize something like a project and then take it further forward. It is not merely the discussion here that should end all these opportunities. This is sincerely what I believe, and the areas which appear very much interesting from me. I am representing an industry, so we should take up that one and we should move further forward. And what we really need to look at, those kind of indications I can certainly provide to the team. Kindly look into this thing with all sorts of sincerity, and then we look forward to commercialization of one or two areas, implementation of one or two areas at the industry level. So this is what I just wanted to share with all of you.
Thank you, Dr. Ji,
Yeah.
for showing interest in technologies. There is one more hand raised. I do not know the name, but lady has raised a hand. Please go ahead with your question.
Thank you, Dr. Ashok Kumar. I would like to, I am representing Hindalco. I am Vaishali Surawar. I am a Chief Sustainability Officer at Hindalco. So
Okay.
I would like to reiterate what Dr. Amit Chatterjee said, that application which you have developed with Johnson Prism tiles, the radiation-free tiles, is really interesting to Hindalco, and Hindalco would like to cooperate. Can we even partner with other industries and take this application or upscale this application? Apart from that, I found few other applications of fly ash very, very interesting. And as an Hindalco representative, I would like to partner with Amfree. For shortage of time, I would not reiterate all those, but I have listed down all those applications in my diary notes. Thank you so much.
Thank you, Vishali, for showing your interest in the technologies developed by CSR Amfree Bhopal. Any more questions? Yeah, there is a hand raised by Shri Mohan Ramanathan, I guess. Over to you, sir.
Yeah, it was excellent. I actually wanted to go at 12, but the papers and the research were so good, I postponed the next meeting. So I have a request to this august audience, and I represent the demolition industry also. I formed the first Indian Demolition Association, where demolition and recycling technologies are being promoted. Some of you have attended the first one in 2019. The next one is coming at 2023. Last time we had called the CBRI director, Roorkee director, and also BMTPC head, Dr. Shailesh Agarwal, and CPWD head, just to spread that such technologies are being welcomed by the industry. My point is, there are a large amount of demolitions happening across India, and I'm involved in the big ones. And these are commercial contracts given by the owner to the demolition contractor, and they want to quickly dispose of the resultant of the demolition, which is the debris. So there's hardly any time given for research unless we involve them, involve you organizations in the much earlier stage, so that you can do sampling, you can do some studies. And I find that that there is no interest from the laboratories to go into the physical site, go into the reality. I have to put it in this forum because there are hundreds and thousands of cubic meters being demolished, and the demolition contractor is not interested in recycling, because unless there is a recycling clause and there is a recycling need, the owners want to escape that clause. The owners say, okay, we need to go ahead with the project, let's not look at it. So my appeal to the heads of the CSIR is how to get involved. You know, you're all busy with your own research, you're all busy with your own programs. If there is a large demolition happening, you lose an opportunity to learn, to document, to recycle the material, and finally it ends up in a useless way, and the contractor ends spending money. I've been trying to push this last at least 6-7 years, and the owners are not sensitized. The consultants don't want to use this material. So there is enough research being in your laboratories. There is enough data. But how to bring these two together? I can sensitize the large demolitions in India, starting from huge projects, industrial and commercial and residential, where you have to quickly get involved if we identify a project. And that's where the problem is, that quickly you're not able to get involved. You need to go for travel sanctions. You need to go for project reports. By the time you get your project reports done, the project is over. So I don't think I'm very skeptical, but I'm very practical. On date, there are huge projects in India. At least 40,000 bridges are going to be demolished for new bridges, and I can go on and on. You must have all heard of the Supertech towers in Noida, which are going to be blasted next month. So unless we have all the things in place, those 100,000 cubic meters of concrete is not going to be recycled. There's no plant nearby to recycle. So CBRI Roorkee is involved in some way in proof checking, but not in the mission of recycling. So I will stop here. I just wanted to put the reality amongst the scientists here. And unless you bring these two together, it does not happen. From the demolition industry, where I'm the chairman of the IDA, I can assure you, if you if you lend your hand and agree to move fast, because these projects are always on fast track, the owner is waiting to make, build something after the demolition, and is really not concentrating on the C&D waste. There is no legislation also to force a owner to go for recycling. Today we do not have we have only guidelines and we have only the code. So I put this proposition to this August audience, and let me know how we can help, how from the demolition industry we can help. But believe me, there's so much going on. There's so much demolition going on. You may not even know what's happening in your backyard, but there's so much going on. Unless we're able to push this now, we are far behind in the whole world on recycling. We hardly recycle 1% of the recyclable material from C&D waste. We are far away. So with this, I will stop. Thank you for the few minutes you gave me, Dr. Ashok Kumar, and I also thank Mr. Ashokan Pappu for bringing me into this audience. Thank you very much.
Thank you, sir, for your wonderful comments, and I am sure both CSIR, CBRI, Roorkee, and Empri Bhopal and others will definitely be in touch with you. And I think our director Anjan Ray would like to say something on this.
No, I don't think I wanted to say anything. I was just saying how much I appreciate Mr. Ramanathan and Mr. Deepak Bansal's talks and interventions. It is a very important area. And I think there'll be a number of pan-CSR collaboration opportunities here, not limited to just the two labs over here, but everything from metals recovery, materials recovery, what Ms. Vaishali Suravar said about broader sustainability issues. And particularly both Tata Steel and Aditya Birla, and Vedanta and Aditya Birla, who talked about sustainability on a broader level, use of sustainable energy, reduction of carbon footprint, reduction of wastes. There are a number of opportunities where we should have such seminars engaging from the industry need point of view. Because when you work in an industry, there are many pain points that we academics don't always pick up. It could be something as simple as something has leached and somebody's cow has died, and then it snowballs into issues out of control. So just being able to work with industry from their needs point of view, the technology that needs to be done, not just the science we need to do, that movement and orientation, I think we need. Mr. Ramanathan also kind of talked about that the ecosystem doesn't always support it. And lab scientists don't always go out into the field and look deep into the field issues. So I feel there is an opportunity here to re-examine the way we work in the larger context of sustainability. Let me leave it at that, but let us also invite all our industry colleagues on this call to set up one-to-one interactions, industry across, so one industry and all of CSIR that might be relevant. Let's have a few of those as a follow-up to this. I see particularly Mr. Devendra Singh nodding his head. He has come from a highly industry-oriented lab, so he knows how closely one can work. Thank you all once again.
Thank you, sir, for your wonderful comments, and we look forward to your direction and your guidance in this area. And now, I think as there are no more questions, I can straight away request Mr. Devendra Singh, Principal Scientist, TMD, CSI Headquarters, for closing and vote of thanks, and further to Dr. Ashokan for overall remarks. Over to you, Dr. Devendra Singh. Or Mr. Devendra Singh.
Am I audible, sir?
Not really. You can come closer to your mic.
Yeah. Am I audible now?
Better.
Yes, sir. Am I audible?
Maybe you can come closer to your mic. You can please increase the volume.
Yeah. I hope I'm audible now.
Yes.
Yeah. Thank you. Thank you, everyone. So I would like to thank CI theme director Dr. N. Anandavalli, who is coordinating all the event on behalf of CI theme, and our industry partners from whom we have listened to the plenary talk, Sri Mohan Ramanathan sir, MD Advanced Construction Technologies, and Mr. Deepak Bansal, Joint GM, Hudico, New Delhi. And I would like to thank Director CSIR CBRI, Dr. Anjan De, and Director CSIR MP, AK Srivastava sir, and the moderator of event, Dr. Ashok Kumar from CSIR CBRI, and event coordinator, Dr. Ashokan Pappu, and the speakers on various topics of waste to wealth utilization, Dr. A.K. Sinha, Dr. M.K. Gupta, Dr. J. Prabhakar, and Dr. J. Santa Kumar, and Dr. Kirti Soni. So this event is the one of the event on the waste to wealth utilization under CE themes, and I have noted the suggestion and comment given by Dr. Amit Chatterjee and Vaishali ma'am from Hindalco, and Mohan Ramanathan sir. So certainly at lab level or the CSIR headquarter level, or maybe at the various ministry at the Ministry of Science or Technology level, wherever we will get the opportunity to raise these points, so that we can collaborate as a R&D setup at the larger level to take the challenges posed by the industry, or come up with some of the R&D solution to the problems which are suggested. And I would like to suggest to the event coordinators, they will take all these points which are commented by the speakers, eminent speakers, and they do these points will be the part of our reports on the events, and maybe the part of the larger suggestion provided by the industry under the CI theme. Then those points will be put forward to the at the secretary level, to the CSR, DBT, DST, and finally to the at the ministerial level. So at the accordingly the problem suggestion and the inputs which are suggested on the during the various iConnect event will be addressed, and will provide the opportunity for the future collaboration and future R&D solutions to the problems. So, and I would like to thank all the participants from the CSIR headquarters side. And certainly we will look forward for the more future collaboration and with the industry. Thank you. Thank you.
Over to you, Dr. Ashokan, for the final concluding remarks.
Thank you very much, Dr. Devenderji. I think before coming to the concluding and closing this event, just I will take few minutes. Let first of all sincerely thank Dr. Ashok Kumar, my senior colleague from our own family Central Building Research Institute, CBRI Roorkee. He is an outstanding scientist, and in the CBRI history, I understand he is the only one scientist so far being outstanding scientist. And he would able to create time and interact with us and organize this today event. And really thank you so much, Dr. Ashok Kumar, for your valuable support in this program. Actually, I addressed that today all participants are there. You might have all enjoyed from today plenary speech from Dr. Mohan Ramanathan and the keynote speech from Dr. Deepak Bansal. And the topic is really very hot, the construction and demolition waste. And it went really very fruitful sharing of information and knowledge. I am sure this technology presentation session chairman, our esteemed director, Dr. Anjan Reis, his valuable advice and the crisp information what he has given to us, which has opened avenues to concentrate on the immediate need in the area of waste to wealth and focus on transformation of the research to commercial applications. And essentially, the speakers from our director and the construction technology and solution industries and HUDCO, their speech is very thought-provoking. And in addition to that, the topic presented by our scientist, Dr. Prabhagar, Dr. Sinha, Dr. Kirti, Dr. Manoj, and Dr. Santakumar, it's really a very, very high TRL, which has immediate application for commercialization. I am sure many MSME, they are participating, and this program is aimed to transform and facilitate entrepreneurship and startup. And we look forward and we believe the entrepreneur and startup is going to approach the concerned scientist to create new opportunities in the context of enhancing the nation economy and creating the employment, and thus safeguarding and sustaining our balanced ecosystem, thus contributing to the government of mission on Make in India, Clean India, and Atmanirbhar Bharat. And a special thanks to our special invite in quickly they could able to join from the industry, especially Dr. Amit Chatterjee, the Vice President, head of the Vedanta R&D Center, Aluminium Center, and Dr. Vishali from the Hindalco R&D head. They could able to join this and share their view. And it has a very important role for R&D and technocrat like us, where to concentrate to address the need of the industry rather than we do research on our own expertise areas. So we will concentrate on the point suggested by Dr. Vishali and Dr. Amit Chatterjee. And we will be having a good association and interaction with you industries to take to the next level. With this, I would like to sincerely thank all the guest speakers, directors, technology presenters, and my colleague here, they are there, Dr. Shukla, Dr. Akram Khan, Dr. Manoj Kumar, and Dr. Tipti, and Dr. Sariya, and our IT colleagues, Narendra Patel, and many other staff members, they are helping in organizing this event. And this is the third event of this Waste to Wealth under Civil Infrastructure Engineering. We have two more events, which is on 14th and the last event panel discussion on 15th of July. I believe this 15th July program is going to have a very important role in connecting the stakeholders, entrepreneur industry, and the startup industry to achieve the Government of India aim on Azadi Ke Amrit Mahotsav and celebrating our 75 years of independence through our S&A transformation with the industry intervention and stakeholder intervention. With this, I once again thank all the Ministry of Earth Science and Ministry of Science and Technology for creating this time. And thanks to all the participants for creating your valuable time in being with us today. And I am sure we look forward to seeing you for realization of today event and sharing of this knowledge for the interest of the society, industry, and as well as for our mutual interest and to meet the government India missions. With this, thank you once again. Namaskar. And formally, we will be closing. I am closing this event today, and we will join on 14th of July. Thank you so much. Namaskar.